So let's say you own a pizzeria and you need to deliver pizzas to your customers as quickly and efficiently as possible. How would you figure that out? You'd use something called graph theory. When you hear the word graph, you might think of this, or even this. Most people associate the word graph with the graphical representation of a data set or a function. But there's also something called graph theory, where a graph is a mathematical model of a network. In graph theory, a graph represents a set of objects. Here, each object is represented by a letter. These objects are called nodes. The relationship between these objects, or nodes, is represented by lines called arcs. Let's connect the objects that have a relationship between them. Graphs like these are used in the business world, manufacturing, transportation, and even the military to figure out the best way to move people, products, data, or energy from one location to another within a network. A network can be any size. This computer chip is a tiny network. The circuitry inside the chip is a series of components, or nodes, which are connected to each other by wires and traces, or arcs. Electric current flows from component to component through the wires and traces, so the designers of computer chips rely on graph theory to help optimize processing speed, or the movement of energy and data through this network. Networks can also be huge. The internet is a vast worldwide network connected by telephone lines, fiber optic cable, and satellite dishes. The servers of your internet service provider act as nodes within this network. Switchers, hubs, and wireless routers allow you to connect to this global network at home or at school. So when you go online, you can access information and websites all around the world. When a network is especially large and complex, like the internet, graph theory can be used to figure out its maximum flow capability. Graph theory can help predict when and where the internet might need to be expanded to improve response times for everyone trying to access social media websites on a typical Friday night. So you have a network that can be any size, represented by a graph, which is made up of nodes, some of which are connected by arcs. What is the quickest way to get from one node to another if they're not connected by an arc? If you can't go directly from A to G in the network, how do you determine the shortest or fastest route between them? The answer to this question is an important one for everyone, from designers of computer chips to first responders like police officers and firefighters who need to get to the scene of an emergency as quickly as possible. In the 1950s, a Dutch-American computer scientist developed a step-by-step procedure to calculate the shortest or fastest routes between two specific locations in a network. Dijkstra's algorithm allows you to solve this problem with pencil and paper, working methodically to solve the distance between nodes that connect your starting point to your end point within the network. This formula can also be programmed into a computer to solve routing problems inside larger, more complicated networks. Dijkstra's algorithm allows many industries to maximize the delivery of products like electronics, mail, or pizza while minimizing their fuel and staffing costs. It's used by school districts to determine the most efficient bus routes and by city engineers working to improve the timing of traffic signals. When you think about it, graph theory really helps to make our lives easier. Everything from GPS to internet search engines are optimized by knowing how arcs connect to nodes in a network. And it's also pretty great for getting pizza delivered.